Hi, second year students. The final session of the limit exercise 1.3. The elegant questions are at the back. To me, there's a deficiency of some questions that can I compensate from somewhere else, and I about to post additional questions in limit. I compensate e raised x minus 1 and a power x minus 1 over x. But for now, let's continue our question number 1. Let me give you a good idea about the identity limit x tends to 0 sin x over x is equal to 1 where x is measured in radians. X is measured in radians where x is measured in radians. This is sin x over x, it's equal to 1 where x is measured in radians, where angle inclination is measured in radians. If we reciprocal this formula, take multiplicative of inverse of this one, it is still valid and equal to same one. Is equal to same one. If there is 2x, there must be 2x, 3x, 3x, 4x, 4x. Whatever the inclination is, inclination must be same in sign as well as in the denominator. In light of this, limit x tends 0 sin x over x is equal to 1, where x is measured in radians. Let's check question number 1. Limit x tends to 0, we have 7 sine 7x over x. Mark my words. First step, put direct limit, it is a real number 0, 1, 2, pi, whatever the case is. X 0, 0, overall 0, it is our indeterminate form if we put direct. But utilizing this identity, we can arrive at somewhere the result. This form is known as indeterminate form. To remove this, let's see and find out. Take the assistance or help of this identity. Limit x tends 0 sin 7x. There is the deficiency of 7. Divide and multiply 7. Look at this. Now it is in the vicinity of this identity. Utilizing this identity, limit x to 0 sin 7x over 7x, it is equal to 1. By virtue of this formula, by virtue of this identity, 1 times 7, the result is 7. The result is 7. Latter matter, it is also known as a removable singularity. As you learn extreme values, maxima, minima, or whatever the case is, we can proceed. Limit x tends to 0 sin x over x, where x is measured in radian, where inclination is measured in radians, is equal to 1. If we take multiplicative inverse or reciprocal of this identity, still this formula identity is valid. Moving towards question number 2, part number 2 of question number 3. Limit x tends to 0 sin x, limit x tends to 0 sin x in degrees overall x is equal to what? Same. If we direct put limit here, x is 0, overall 0 is indeterminate form. We have to get rid of this 0 by taking the assistance of same identity. Limit x tends 0 sin x over x is equal to 1. But inclination must be measured in radians. We have there the degree, degree. We have to convert degree into radian. By utilizing tiny fact of trigonometry, 2 pi radians is equal to 360 degrees. 2 pi radian is equal to 360 degrees. We want to convert degree into radian. Shift 360 here. 2 pi over 360 is equal to 1 degree. Applying table of 2, pi over 180 is equal to 1 degree. Is equal to 1 degree. So if we want to convert x degrees into Meyer, multiply with pi over 180, pi over 180, pi over 180. So we are going to have something like this. Limit x tends 0, 7 sine x times pi over 180. Now it is in radian. I am not writing this degree. We have got rid of this degree. Overall x. Overall x. Now, what the inclination here? X times pi over 180. We also need x pi over 180 here. X times pi over 180 here. X times pi over 180 here. So compensate the deficiency by dividing and multiplying. Limit x tends to 0. It will become sine pi x over 180. Multiply and divide with pi over 180. Pi times x over 180. Divide as well as multiply pi over 180 here. There is x degree. This formula is valid for radians. We have taken the assistance of 2 pi radian is equal to 360. We have utilized this. We have x degrees multiplied by pi over 180 in order to convert degree into radian. Degree into radian. We did so here. We did so here. And then after this, we have inspect the situation like the sine 7x over x. There is deficiency of 7. By the same virtue, there is deficiency of pi over 180. Pi over 180. So we have divided as well as multiply. Now it is valid identity same. By virtue of this identity, it's equal to 1. 1 times pi over 180. 1 times pi over 180 or pi over 180 is our answer in that case. Is our answer in that case. First identity sin x over x is equal to 1 where inclination or angle is measured in radians. Measured in radians. Moving towards next question, that is limit theta tends to 0 here. Variable is theta. Theta tends to 0. 1 minus cos theta divided by sin theta. 1 minus cos theta divided by sin theta. Let's open this up. Limit theta tends to 0 approaches to 0. 1 minus cos theta overall sin theta. Overall sin theta. Put direct limit. Sin 0 is 0. So here again it is indeterminate form. Indeterminate form. We have to got rid of this overall 0 in the denominator from this. You have several possibilities. The first, just rationalize. Let's see and find out. Limit theta tends to 0. 1 minus cos theta then divided by sin theta. Rationalize, multiply and divide by 1 plus cos theta. We are familiar whenever we rationalize difference of two square situation props up. Whenever we rationalize difference of two square situation props up, whether in numerator or denominator, difference of two square situation props up. So in numerator we have 1 minus cos theta times 1 plus cos theta, it is equal to 1 square minus cos square theta overall sin theta times 1 plus cos theta. By virtue of this identity, a square minus b square is equal to a plus b times a minus b. 1 minus cos square is equal to sin square. Utilizing tiny fact from the trigonometry of 10th grade, even 8th grade, sin square plus cos square is equal to 1. Sin square plus cos square is equal to 1. Provided that inclinations are same, angle is same here. So instead of 1 minus cos square, I can write, if I shift cos square here, sin square is going to be 1 minus cos square. So instead of 1 minus cos square, I can write sin square. Limit theta tends to 0. Sin square theta overall sin theta times 1 plus cos theta. Applying table, we have a sin theta in the numerator. Limit theta tends to 0. Sin theta overall 1 plus cos theta. Something cancelled out. Let's check by putting limit again in the denominator. 1 plus cos 0 is equal to 1. 1 plus cos 0 is equal to 1. 1 plus 1 is equal to 2. So denominator is not 0. It's our answer. So we have sin 0 overall 1 plus cos 0. Sin 0 is 0. Cos 0 is 1. 0 over 2. 0 is the answer in that case. 0 is the answer in that case. We never want, unwanted thing is 0 in the denominator. Overall 0 in the denominator. Let's see and find out. You can utilize another fact, half angle formula. That is, let me share with you, 1 minus cos theta. From trigonometry, limit theta tends 0, 1 minus cos theta is equal to 2 sin square half angle divided by 2. Half angle divided by 2. This formula comes or occurs from this formula. Sin square is equal to 1 minus cos theta over 2 and cos square is equal to 1 plus cos 2 theta over 2. Look at this. Their angle is half, their angle is double. Their angle is half, their angle is double. So we are coming back from double to half, from double to half, from double to half. We have only theta. Half of theta is theta over 2. Half of theta is theta over 2. I have written. Okay. Then another identity. Limit theta tends to 0 to sin square theta over 2 sin theta. By virtue of this formula, sin 2 theta is equal to sin theta cos theta here. Double angle here is half. So here is sin theta. I can write 2 sin theta over 2, half the angle, cos theta. Sin theta can be written as 2 times sin theta over 2 cos theta over 2. So 2 sin theta over 2 cos theta over 2. 2 cancel, a single sign remains in the numerator. Limit theta tends to 0 sin theta over 2 divided by cos theta over 2. If we put limit theta 0 over 2 0, cos 0 is 1, cos 0 is 1 and sin 0 is 0. So there is no more 0 in the denominator. We are done with that. 0 over 2 means 0, cos 0 is equal to 1 and here sin 0 over 2, sin 0 is 0 while cos 0 is 1, cos 0 is 1. So it is defined form 0 over 1 is equal to 0, is equal to 0. It's up to you whether rationalize or take that path. You must be familiar from these identities as they work for you in incredible manner. Incredible manner. They will assist you where most things leave you. Okay, question number next 4. Limit x tends to pi sin x over pi minus x. If we put direct limit pi minus pi, denominator is 0, so we don't want 0 in the denominator. Let's see how. Limit x tends to pi. We have sin x over pi minus x. Pi minus. Check the denominator by putting limit as it is a real number pi minus pi. 0 in the denominator. Indeterminate form. Indeterminate form. Get rid of this 0 if possible. Why not? It's possible. Utilizing simple trigonometry, sin x can be written as sin pi minus x. Sin alpha minus beta, pi minus x over pi minus x. Let me show you the equivalence. It is equal to this sin pi minus x. Utilizing identity sin alpha minus beta, sin alpha cos beta negative cos alpha sin beta. Sin pi is 0, 0 times cos is 0 and cos pi is equal to minus 1 times sin x. Minus minus plus, so it is again sin x. So it is safe to write sin x as sin pi minus x, sin x as sin pi minus x. To convert this into that form, that formula we are familiar with, limit x tends to 0, sin x over x is equal to, or you can direct apply limit here, But let me change the shape towards this. Suppose x are old variable. Suppose x is equal to limit plus u variable. X is equal to pi plus y such that y tends to 0. If I put y here, then we have same x tends to pi, x is pi, x is pi. How to suppose in case of limit? Old variable is equal to limit plus new variable, limit plus new variable, limit plus old variable is equal to limit plus new variable such that new variable tends to 0, new variable tends to 0. If y is 0, then we have x tends to pi, same x is equal to pi. Switching over this limit here, now we have limit y tends to 0, sine pi minus, instead of x, I can write pi minus y, pi plus y, sorry, overall pi, instead of x, let me write pi plus y, pi plus y. Multiply this minus, it will become negative pi, negative y, negative y. Let's open this up, limit y tends to 0. We have sin pi minus pi minus y. Overall, pi cancel, pi minus y cancelled out. What we are left with? Limit y tends to 0. We have sin negative y, overall negative y. Sine is an odd function. Sine is an odd function. Minus must be retained at the start. Minus must be retained at the start. So it is equal to minus sin y over minus y. Sin y minus cancel. Minus cancel. We have same situation, limit y tends to 0. Sin y over y, same identity. It is equal to 1. It is equal to 1. It is equal to 1. So our answer in that case is 1. Answer in that case is 1. Answer in that case is 1. Put direct limit, denominator is 0, try to get rid of this one. X can be written as pi minus x. I have shown you the equivalence. Sin pi minus x, apply sin alpha minus beta from first year. Sin alpha cos beta, cos alpha sin beta. Sin pi is 0, cos pi minus 1. So again we have sin x. So instead of sin x, I have written pi minus x in order to show and make the angle inclination same. Again, in order to convert the shape towards this one, old variable, suppose old variable is equal to limit plus new variable such that y tends to 0. Old variable is equal to limit plus new variable such that y tends to 0. Just now y is 0. Put instead of x pi plus y, you will get this shape as we have here. Sin y over y tends to 0, it is equal to 1. And we are familiar where y and inclination angle is measured in radians. Angle is measured in radians. Okay. Moving towards question number 4. Sin ax, limit x tends 0, sin ax divided by sin bx. Whatever we have, let's see. Question number 5. Limit x tends to 0, sin ax divided by sin bx. Yes, put direct limit. B times 0 is 0 and sin 0 is 0. So here again denominator is 0. Denominator is 0. Sin 0 is equal to 0. Get rid of this one. Utilizing same identity, limit x tends to 0. Sin x over x, it is equal to 1. It is equal to 1. Here we have two functions of sin ax, sin bx. I can write this as limit x tends to 0, sin ax times 1 over sin bx. 1 over sin bx. Let me write dot here for multiplication in order to not get confused x and multiplication. Look at this formula. There is deficiency of ax, there is deficiency of bx. Compensate that by dividing and multiplying. We have limit x tends 0. We have sin ax overall ax. Compensated, divide as well as multiply. Look here. 1 over sin bx, divide and multiply by bx. Now it's very safe, it's equal to 1, it's also equal to 1. We have 1 times ax overall 1 times bx. X cancelled out, x cancelled out. We have a times 1 over b, or a over b is our final answer in that case. A over b is our final answer in that case. For direct limit, denominator is 0. Try to get rid of this one. Here, two functions of sine. I open this up. Sine ax times 1 over sine bx. There's deficiency of x divided multiply. There's deficiency of bx divided multiply. Again, we have variable, but eventually they are, without doing anything, x cancelled out. We have safe answer a over b. A over b. Moving towards sixth question. Sixth part of question number 3, that is limit x tends 0 x over 10 x over 10x. In case of trigonometric function, sin x over x works 1 to for us. Limit x tends 0 x over 10x. Here we have x 10 10x 10 0. 10 0 means sine 0 over cos 0. Sine 0 is 0, cos 0 is 1. So it is 0. So tan 0 is 0. Tan 0 is 0. Again, it is indeterminate form. Indeterminate form. We have to get rid of this 0. Simply utilize tan is the ratio of sine and cos. Limit x tends 0. X over sine x over cos x. Still it is a valid formula. Sine x over x or x over sine x. As I have told you on the outset, limit x tends 0. Sin x over x is equal to 1, or its reciprocal is also equal to 1. X over sin x is equal to 1. So it's equal to 1 over, and cos 0 is 1. 1 over 1, 1 is our answer. 1 is our answer. Or one can write in that fashion, or limit x tends to 0. We have answer in that case. Limit x tends to 0, x over 10x. Divide can be written as like this, 10x, and 10x is equal to ratio of sine and cos, x divided by sine over cos. Convert this division to multiplication. I have x times cos x over sine x. If I write them together, x over sine x times cos x, it's equal to 1, and cos 0 is also 1. 1 times 1 is 1 mine answer. 1 mine answer. Okay. Cool. Moving towards next question. Limit 1 minus cos 2x over x square is equal to what? Evaluate this limit. Definitely, if we put direct limit, denominator is 0, 0 square is also 0. Let me write how. Question number 7. Part number 7. Limit x tends to 0. 1 minus cos 2x over x square. Either it's up to you, or rationalize 1 plus cos 2x divide or multiply, or put direct identity of this one that I have told you. 2 sine square x. Double, here is double, half the angle. 2x, half of 2x is x. Overall, x square. Now, limit x tends to 0. Limit x tends to 0, it's equal to 1. 2 times 1, 2 is our answer. 2 is our answer. If one is not satisfied with this, okay, go ahead, rationalize. I have utilized this fact. Sine square is equal to 1 minus cos 2x over 2. I need value of only 1 minus cos 2x. I have taken 2 here. So 2 sine square x is equal to 1 minus cos 2x. Instead of 1 minus cos 2x, I have written sine square. Here already x square, it's our identity, it's equal to, or one can adopt the strategy of rationalize. Rationalize, changing the main symbol, 1 minus cos 2x, x square, divide and multiply by 1 plus cos 2x divided by 1 plus cos 2x. Whenever you rationalize, difference of two situation pops up, whether in numerator or denominator. We are rationalizing according to numerator, so difference of 2 square situation pops up in numerator. It's 1 square minus cos square 2x over x square times 1 plus cos 2x. 1 minus cos square is equal to sin square, and that I have also given you. You are familiar with this. Sin square is equal to cos square. If I need value of 1 minus cos square, it's equal to sin square. So I have limit x tends to 0. 1 minus cos square 2x is equal to sin square 2x divided by x square here 1 plus cos 2x 1 plus cos 2x here. Look at this. There is x square, there is 2x, there is x square. Okay, let me settle down this. If I put limit here, cos 0 is 1, cos 0 is 1, sin 2x over x overall square. There is square, there is square. I have written in that fashion into 1 plus cos 2x. Here, there is 2x, there is dearth of 2x. Divide and multiply by 2x. Divide and multiply by 2x. I have little space. Let me manage the show here. Multiply as well as divide here. Now it's equal to 1. It's equal to 1. There is 2 square. There is 2 and square. It's equal to 1. Sin 2x over 2x. I have make the angles inclinations identical by dividing and multiplying 2. Sin 2x over 2x, it's equal to 1. There's 2. 2 times 1 is 2 square. So I have 2 square into cos 0 is R1. Cos 2 times 0 is 0. 2 square means 4 times 1 plus 1. 4 times 1 over 2 cancelled out. 2 is our answer. 2 is our answer as we have concluded earlier. So 2 is the answer whether to take this path or that path by putting direct limit 2 sine square x overall x square. It's equal to 1. 1 times 2 is 2. Whether to adopt this strategy, but these formulas works wonder for you in differentiation as well as integration. So you must be familiar, you have good grip over them. Grapple the situation by utilizing these formulas, sine 2x, cos 2x, tan 2x, as well as in half angle formula, these two, they works wonder for you. Moving towards question number 8. I have one minus cos x, whether rationalize or direct put formula, it works wonder for you. Limit x tends to 0, 1 minus cos x overall sin square x. You can rationalize by dividing and multiply 1 plus cos x, or 1 minus cos x is equal to 2 sin square x upon 2. Let me start this with 100% different strategy. Limit x tends 0, 1 minus cos x, putting direct limit sin square 0, sin 0 is 0, so denominator is 0, it is indeterminate form. If I write instead of sin square 1 minus cos square, it is safe to write 1 as 1 square. Applying difference of 2 square situation in denominator, I have 1 minus cos x overall, 1 minus cos x, 1 plus cos x cancelled out. Put limit here, 1 over 1 plus cos 0. Cos 0 is 1, 1 plus 1, 1 upon 2. Either to take this part or rationalize or utilize 1 minus cos, you will arrive at the same result. Let me rationalize as well. Limit Paliter method, limit x tends to 0, 1 minus cos x overall sin square x here. Divide and multiply by 1 plus cos. 1 minus cos, 1 plus cos, difference of 2 square situation. It's equal to 1 minus cos square, limit x tends 0. 1 square minus cos square overall sin square x times 1 plus cos x. 1 minus cos square is equal to sin square, dividing by sin square times 1 plus cos x cancelled out. Cos 0 is 1, 1 over 1 plus 1. 1 upon 2 is our answer, or one can switch over to the identity 2 sine square x upon 2 and okay, let me try this one as well. Adopt another strategy, same. Limit x tends to 0. The third method, 1 minus cos x can be written as 2 sine square x over 2. This sine x can be written as in half angle 2 sine x over 2 cos x over 2. We have 2 times sine square x over 2 divided by this is 4 sine square x over 2 cos square x over 2. 1 to the 2, 2 to the 4, sine square cancelled out. What remains? 1 over 2 cos square x over 2. Cos 0 is 1. Cos 0 is 1. 2 times 1 is 1 over 2. 1 over 2. Adopt any strategy, you will arrive at the same result. Keep in mind that we have to get rid of this 0 in the denominator. Whenever there is a trigonometric functions, there is a probability of this formula to help you out. Sin x over x is equal to 1. Don't forget where x is measured in radians. X is measured in radians. Question number 9. Question number 9. That is limit theta tends to 0 sin square theta divided by theta. Good one. Limit theta tends to 0 sin square theta divided by theta. For direct limit, denominator is 0, we don't want. There is already formula hidden in that. Sin square can be written as sin times sin theta divided by theta. It's equal to 1. By virtue of this formula, limit theta times 0 sin theta over theta, it is equal to 1 times sin 0. Sin 0 is 0, 1 times 0. 0 is our answer in that case. 0 is our answer in that case. We can afford 0 in the numerator, but not in denominator. Now, last 3 questions, to me, humongous, impressive questions. Last 3 of this trigonometry. It is base making, giving you idea. Now, these 3 questions are humongous questions from exam point of view, from entrance test point of view. They are good one, brilliant one. Question number 10, limit. It is the first question that you are learning today. Limit x tends to 0, sec x minus cos x divided by x. Put limit direct, denominator is 0 obviously. Indeterminate form. Try to get rid of this one. Whether you are solving trigonometric question in limit, differentiation, integration, even in trigonometry, try to convert complete functions in sine and cos. Try to convert all functions in sine and cos. It will pave the way for your facilitation. Then you are in a position to sail through. It can be written as sec x minus cos x divided by x. Convert all the functions if possible in sine and cos. It is already in cos. Convert this one into sine or cos. Sec is the reciprocal of cos. Instead of sec, I can write 1 minus cos. Overall cos. Deviant can be converted into multiplication by taking its reciprocal or multiplicative inverse. LCM, limit x tends to 0. Cos x is the LCM, and I have 1 minus cos square x times 1 over x. X0, denominator 0, we don't want 0 in the denominator. Such type of questions are present in differentiation, integration, wherever it is. Try to convert complete trigonometric function in sine and cos. It will start your vehicle, it will start your understanding, it will pave the way for your journey in a simple fashion. Sec is written as 1 minus cos, taking LCM. Bingo, 1 minus cos square, it is identity of sine square. Limit x as 0. I have sine square x overall cos x times x. Here again, sine over x can be separated, it's equal to 1, and there is no more 0 in the denominator. Limit x tends to 0. I have sine x times sine x over on x and cos x. Here, sine x over x, by virtue of this same formula, limit x tends to 0, sine x upon x, sine x upon, sine x upon x, sine x upon x, it's equal to 1, it's equal to 1. Sine 0, 0, cos 0, 1. Let me write here sin x over cos x times 1. Now put limit, it's our sine 0, cos 0, 0 over 1, 0 is our answer, 0 is our answer. We can afford 0 in numerator but not in denominator. Sec x minus cos x, something typical to negotiate, try to convert all trigonometric functions in sine and cos. It is already in cos, instead of sec I have written 1 over cos. Taking LCM, 1 minus cos square is equal to sine square. If I split sine square and sine into sine, it is our formula, it is our identity. Sine x over x is equal to 1. Here, sine 0 is 0, cos 0 is 1, 0 or 1, 0 is our answer. Moving towards next question, impressive one. Limit theta tends to 0, 1 minus cos p theta, 1 minus cos q theta is equal to what? Let's see and find out. To me, impressive question it is. Limit theta tends to 0, we have 1 minus cos p theta over 1 minus cos q theta. Put direct limit in denominator, 1 minus cos q times 0, 1 minus cos q times 0 is also 0, cos 0 is 1, 1 minus 1 means 0 in the denominator, 0 in the denominator. We cannot simply applying same formula, 1 minus cos x is equal to 2 sin square x upon 2. We have to rationalize double time with respect to 1 minus cos p theta, 1 minus cos q theta. It is going to be cumbersome, lengthy. Just utilize these two formulas. They will pave the way for our facilitation. 1 minus cos means 2 sin square half the angle p theta over 2 divided by 2 sin square q theta over 2. 2 cancelled out. Still I put limit here. Q times 0 is 0, 0 over 2 is 0, sin 0 is 0. So I have to look for same formula, limit x tends to 0, sin x over all x is equal to 1. Here, limit theta tends to 0, I can write this as sin p theta over 2 times 1 over sin q theta times 2 overall square. Here there is the dearth of p theta over 2, here the dearth of q theta over 2, divide and multiply in order to make this formula. Switch over to this formula. There is a square, I have written sin square cos square, I have written overall square. So limit theta tends to 0, sin p theta over 2 divide as well as multiply p theta over 2 times 1 over sin q theta over 2, divide and multiply by q theta over 2, divide as well as here multiply overall square. It's equal to 1, by virtue of formula. What we are left with? 1 times p theta over 2 times 1 over q theta times 2 overall square. P theta over 2 cancel. We are left with p over q whole square. P times 1 over q whole square. It's equal to p square overall q square. Answer of this question is p square overall q square. P square overall q square. P square overall q square. We have done with trigonometric limits. Now let's see famous Euler number E, that's equal to 2.71828, written as Euler, pronounced as Euler. It has two forms that leads to E, that's equal to 2.71828. E along with pi is a famous irrational number. Famous irrational number. Let me write two formulas for you. Limit x tends to infinity, it's 1 plus 1 over x raised x is equal to 1. Look at this. There is 1 over x, power is reciprocal of this one. In case of infinity, there is overall power variable. In case of infinity limit, there is overall power variable 100% its formula of E along with some deficiency that you have to compensate. Keep in mind that there is 1 over x, there must be reciprocal of 1 over x, there must be x over 1. And second form of this formula with little variation, limit x tends to 0, we have 1 plus x raised 1 over x. They both are exchanged. 1 over x goes into power and x comes into numerator here. 1 plus x is 1 over x. Almost concept is same. There is x over 1, there is 1 over x. Reciprocal of each other. It is equal to E. E. That form for 0. Limit x tends 0, 1 plus x raised 1 over x is equal to E. And in case of infinity, limit x tends 0, 1 plus 1 over x raised x is equal to E. It's sure when we have in case of 0 or infinity, in case of 0 or infinity, overall power is variable, overall power is variable. These are the forms of E, direct or indirect with little variation. They leads us to E, that's equal to 2.71828. 2.71828. Let's create question number 1, that is limit n tends to infinity 1 plus 1 upon n raised to n. 1 plus 1 upon n raised to n. Raised to n. Look at the formula. 1 plus 1 upon x, there must be x over 1. There is 1 over n, we need n over 1. There is 2 in surplus, 2 is extra. Manage the 2, manage the 2. It can be managed very easy. Limit n tends to infinity 1 plus 1 upon n raised n. 2 can be written as power having another power. 1 over n, there is n over 1, it's equal to E. E raised to. E square is our answer in that case. E square is our answer in that case. Moving towards question number. Next, let me raise this in order to save, in order to make space. Limit n tends to infinity. Here, positive infinity is mentioned. It's okay. 1 plus 1 upon n raised n over 2. Raised n over 2. 1 plus 1 over n raised n over 2. Overall power is variable. E, limit n tends to infinity, overall power is variable. Its form of E, just compare with this one, 1 plus 1 upon x raised x. 1 plus 1 upon n, we need n. We don't need 1 over 2. Try to manage 1 over 2 as limit n tends to infinity, 1 plus 1 upon n raised n, overall raised 1 over 2. N over 2 can be written as n times 1 over 2. N over 2 can be written as n times 1 over 2. There is 1 over n, there is n over 1. 1 over n, n over 1. They are reciprocal to each other. It's equal to E 1 over 2. E raised 1 over 2 is our answer in that case. E raised 1 over 2 is our answer in that case. Second one is 1 minus 1 upon n raised n. Okay. Question number 3, limit n tends to positive infinity, negative infinity, it's okay. 1 minus 1 over n raised n. Look at this, there is negative sign. There is minus 1 over n, negative 1 over n. We need negative n over 1. We need negative n over 1. There is deficiency of minus. There is deficiency of minus, compensate this. Limit n tends to positive infinity, 1 plus minus 1 over n. In order to give you a good idea, there is minus 1 over n, we need negative n over 1. Negative n over 1. Actually, there is positive n, there is a negative n. Let me write minus 1. Power is minus 1. Minus 1. Minus minus plus. Now, it's fit case for E. Minus 1 over is minus 1 over n, there is minus n over 1. It's equal to E in case of infinity. E raised minus 1, or it can be written as 1 over E. 1 over E is our answer in that case. Similarly, 1 over 3n 1 over 3n limit n tends to infinity 1 plus 1 over 3n raised n. Look at this. Limit infinity overall power variable, it's case of E. Case of E, let's reconcile with our fact. There is 1 over 3n, there must be reciprocal of this one. 3n over 1, 3n over 1, 3n over, there is deficiency of 3. Divide and multiply by 3 in power. Limit n tends to infinity, n tends to infinity, 1 plus 1 over 3n raised 3n, that is 1 over 3n, there is 3n over 1, overall 1 over 3. We have multiplied as well as 3 in the power. We have multiplied as well as 3 in the power in order to make the situation. There is 1 over 3n, there must be reciprocal of this one, 3n over 1, 3n over 1. It's equal to E, it's equal to E raised 1 over 3, raised 1 over 3. E raised 1 over 3 is our answer. E raised 1 over 3 is our answer in that case. Moving towards the final phases of the questions. 1 plus 4 over n, it's easy. Okay, let me manage all these. Limit n tends to infinity, positive or negative, it's okay. 1 plus 4 over n raised n. Limit infinity, overall power variable. Limit n tends to infinity, overall power and variable. We have to make reciprocal of this one in the power. 4 upon n, there must be n upon 4. There must be n upon 4. Limit n tends to positive infinity or negative. 1 plus 4 over n. Here must be n over 4. Divide and multiply by 4. Divide and multiply by 4. So, it's fit case of E raised 4, our answer. E raised 4 is our answer. What about this? Next question number 5, 6. Limit x tends to 0. 1 plus 3x raised 2 over x. In case of 0 or infinity, overall power is variable. If overall power is variable, it is a case of E. There is 3x over 1. We need 1 over 3x here. We need 1 over 3x. Divide by 3, multiply by 3. Limit x tends to 0. 1 plus 3x raised 1 over x overall 2. 2 over x can be written as 2 times 1 over x. There is deficiency of 3. Divide as well as multiply by 3. Divide as well as multiply by 3. Divide as well as multiply by 3. There is 3x over 1. There is 1 over 3x. It's equal to E. E 2 3 is 6. E raised 6 is our answer in that case. E raised 6 our answer in that case. Okay. Moving toward 3 to 4 questions. Okay, I got tired. Enough. Limit x tends 0. 1 plus 2x square raised 1 over x square. 1 over x square. Okay. Yes, cool. There must be reciprocal of this one. There is dearth of 2. There is dearth of 2. Divide and multiply by 2. Divide and multiply by 2. Limit x tends to 0. 1 plus 2x square overall 1 upon divide as well as multiply by 2. Divide as well as multiply by 2. It's fit case of, in case of 0 or infinity, overall power is variable. We need the reciprocal of this one in the power 2x square. There must be 1 over x square. We have divided and multiplied by 2. It's equal to E. E raised to. E square is our answer in that case. E square is our answer in that case. Second loss, it's question number 8. Limit h tends to 0. It's simple one. 1 minus 2h raised 1 over h. In case of limit 0 or infinity, it's fit case, overall power variable. It's fit case for E. There is minus 2h over 1. There must be reciprocal of this one. 1 over minus 2h. 1 over minus 2h. Try to make the same shape in the power. Limit h tends 0. 1 plus minus 2h. Reciprocal of this one. There is h, divide and multiply by 2. Divide and multiply by minus 2. Divide and multiply by minus 2. There's 2h over 1, negative 2h over 1. There's reciprocal 1 minus 2 over h. There is h, deficiency of 2, negative 2 divided as well as multiply. Its fit case for e raised to minus 2 is our answer in that case. E raised to minus 2 is our answer in that case. Question number 9 is the important case question in case of E. Question number 9 is Shama and Mafel, let me say that. In case of E, limit x tends to infinity, x over 1 plus x raised x. Look, in case of infinity or 0, overall power is variable, it fit case for E. It's fit case for E. But for E in infinity, we need some situation like this. Limit x tends to 0, 1 plus 1 over x raised x. 1 over x is fit. There is something like this. If I write, first step make or break. If I write this one as 1 over 1 plus x divided by x over all x. This x can be written in double denominator. This x can be written in double denominator. Okay. Limit x tends to infinity. Now divide separately 1 over x plus x over x raised x. 1 over x plus x over x cancel. It's 1. Limit x tends to infinity. I have 1 over 1 upon x plus x. Sorry, 1. 1 plus x over 1 over on x. Now distribute the power. Distribute the power. 1 over 1 plus 1 upon x over on x. So there is x over 1. There is 1 over x, there is x over 1. Limit x tends to infinity. It can be written as 1 over 1 plus 1 over x raised x. Distribute the power x. 1 remains same. 1 plus 1 upon x raised x. Now it's e 1 over x, there is x over 1. 1 over e or e power minus 1 is our answer in that case. Is our answer in that case. Let me explain this one again. X 1 plus x. I have written x in double denominator. It can be converted into numerator as well. Divide separately 1 over x, x over x. X over x here in that case. If there is 1. Distribute power and make this something 1 plus 1 upon x in form. That's 1 plus 1 upon x raised x. It's a formula of E, or one can write in another fashion this question. Limit x tends 0. Take x common from denominator. X common. X common I can write 1 over x plus x over x raised x. X cancel out here. X also cancelled out. Limit x tends to infinity. 1 plus 1 upon x plus 1 here over on x, or 1 upon, make this set like this, 1 first, 1 upon x, then it's equal to x. Here it's formula of E in the denominator 1 over E, or e raised minus 1 is our answer in that case. Is our answer in that case. Thanks God. Moving towards two good questions as well. Very complicated. Limit x tends to 0, e raised 1 over x minus 1, e raised 1 over x plus 1, where x is less than 0. X is less than 0 means negative. X is less than 0 means negative. X is less than 0 means negative. How to handle this? Suppose y is equal to 1 over x. 1 over x. As x tends to infinity, then y tends to, x tends to 0. X tends to 0, then y tends to infinity. Here, suppose y is equal to 1 over x. Limit of x is 0. 1 over 0 means y is infinity, y is infinity. So I can write limit y tends to infinity, instead of 1 upon x e raised to y minus 1 overall e raised to y plus 1. Here it's mentioned to us x is less than 0, so does y less than 0. Y is negative, y is negative. How to handle this? Y is negative, y is negative, y is negative, y is negative. If it approaches towards negative infinity, how we can handle negative infinity or positive? We need they in the denominator, e 1 over x. Limit x tends to infinity. Let me write here to clarify the situation. In case of infinity, limit x tends to infinity. We need this situation, 1 over x, 2 over x, 1 over x square plus 1, whatever the case is. We need variable in denominator. By virtue of this, they all tends to 0. They all tends to 0. Whether infinity is positive or negative, they are going towards 0. If we distribute 1 to 1%, to 2%, to 3, as we enhance the denominator, the quantity diminishes, the quantity vanishes, the quantity decreases, goes towards 0. That concept we have to utilize. We need this variable in upon. So I can write this as limit y tends to 0. This y can be written as 1 over e raised to negative y minus 1. Overall, 1 raised e raised negative y plus 1. Here we have supposed y is equal to 1 over x and x is less than 0. So does y is less than 0. As y is negative, positive. In that case, denominator increases. So does in that case, denominator increases. So this is equal to 0 in case of infinity. In case of infinity, it's 0, it's also 0. It's 0, it's also 0. So we have 0 minus 1 over 0 plus 1. Minus 1 over 1. Minus 1 is our answer in that case. Look, suppose y is equal to 1 over x. It is mentioned x is negative, so does y, going towards infinity or negative infinity. E raised y, we cannot decide. We need this variable in the denominator. If in case of infinity, it is in the denominator, then it's the quantity diminishes. Y is negative. I have written in 1 over e minus 1. Negative, positive. Now this quantity is positive. It increases. But 1 over e raised minus y decreases. It overall decreases. E minus y increases. 1 over e raised minus y decreases. So does this. In case of infinity, it's equal to 0. So does this. It's equal to 0. 0 minus 1, 0 plus 1. Minus 1 is our answer in that case. Almost replica is the second question in that case. E raised 1 over x minus 1. So here x is only positive. How to handle this? Let's see. Limit, same question with x is greater than 0 in that case. E raised 1 over x minus 1. E raised 1 over x plus 1, where x is greater than 0. Suppose y is equal to 1 over x. As x goes to infinity, x goes to 0, y goes to infinity. Here x goes to 0, y goes to infinity. So our limit is y tends to 0. Y tends to infinity, e raised y minus 1 overall e raised y plus 1. Here x is positive, so does y. So there is no need to carry y in the denominator. Unlike in that case, limit y tends to 0, y tends to infinity, e raised y minus 1 overall e raised y plus 1. Here x is less than 0, so does y is less than 0. In that case, we have to make this positive. As y is negative. So I have written limit y tends to infinity, 1 over e raised minus y minus 1, 1 raised e negative y plus 1. So this denominator increases, so this quantity diminishes. Denominator increases, It is negative symbol, y is also negative. Minus minus positive, denominator increases, the quantity overall decreases. Denominator increases, the quantity overall decreases. So it is 0 minus 1, it is 0 plus 1. Minus 1 is our answer in that case. In that case, it is already positive. It is already positive. Take e raised to y common. E raised by common, what remains? 1 minus 1 over ey divided by e raised to y common, 1 plus 1 over e raised to y. These are cancelled out. As y is positive, quantity increases, e raised to y increases, overall 1 over ey decreases. E power y increases, denominator increases, so the quantity 1 over ey decreases. It goes to 0, it also goes to 0 in case of limit y tends to infinity. So I have, in that case, where x is greater than 0, y is greater than 0, 1 minus 0, overall 1 plus 0. So 1 is my answer in that case. It's my tiny effort for you guys of limit, but there is a dearth of these for two formulas, and their question a raised x minus x is equal to 1 and a raised x minus 1 overall x is equal to ln a. These two questions of these two identities and question on these two identities are not present in your book. I can generate from somewhere here and there and give you good idea about comprehensive limit. It's all by itself. Next.